Hello, hello. Welcome to another day, another dollar. Well, actually, another day, another LeetCode question. Today, we are going to do LeetCode live streaming and we're going to focus on medium questions. Today is Thursday, September 29th. Tomorrow's the last day of the month. Looking forward to a lot of things coming in the near future. We're currently sitting at 301 questions, so a very nice milestone that we just hit yesterday. We passed 300 questions, which is amazing. I've gone ahead and I've updated my website, so now it includes a lot of the questions that we've been looking at in the past couple of times. So now we're sitting at 154 easies and 4 mediums. Hopefully this is useful for everyone. John Taylor says, hope all is well. Only wind, rain, tree, and palm branches up here in Gainesville, Florida. Oh, I hope everything's going all right for you guys. Did like the brunt of the storm already pass you guys? I'm like pretty much, okay, so it seems like 11 a.m. Thursday. Okay, so it looks like it's already past Florida now, so that's nice. Yeah, hopefully it hasn't been too bad for you all. Hopefully you haven't lost electricity. And if you do, I hope you have a generator or something. I had actually ordered a generator for the first time, but Amazon canceled it. I guess I ordered it too soon to the event. I had ordered it maybe like 4 days before they said it was gonna hit Florida. It was supposed to come like next day or 2 days after, and then they canceled it. So awesome. I'm glad to hear that, John. Thanks. Or that's good that it wasn't too bad. All right, so we're gonna go to algorithms, difficulty, medium, sort by acceptance, and we'll just go ahead and continue on from around where we left off. So some of these, like, we looked at this one last time, I think barely. I was like feeling really tired when I got to this one last time. So let's start off with this one today. I'm feeling better today. I just finished having like a nice steak lunch. I made myself some steak and I had some steak and white rice, and that was like awesome. And I had blackberries too, so that was pretty cool. Okay, number of laser beams in a bank. Anti-theft security devices are activated inside a bank. You are given a zero-indexed binary string array bank representing the floor plan of the bank, which is an m by n 2D matrix. Bank I represents the ith row, consisting of zeros and ones. Zeros means the cell is empty, while 1 means the cell has a security device. There is one laser beam between any two security devices if both conditions are met. The two devices are located on two different rows, R1 and R2, where R1 is less than R2. For each row I, where R1 is less than I is less than R2, there are no security devices in the ith row. Laser beams are independent. In other words, one beam does not interfere or join with another. Return the total number of laser beams in the bank. So let me see. Between each of the following device pairs, there is one beam. In total, there are 8 beams. So row 0, column 1 to row 2, column 1. Now, note that there is no beam between any device in the 0th row with any on the 3rd row. This is because the 2nd row contains security devices, which breaks the 2nd condition. So there needs to be... Oh, so they need to be at least one row. Well, I guess how would that... Oh, wait, I see. There's 1... here and 2, 3, 4, 5, 6. But they're saying there's 8. And how come there are beams here? Is that because R1 is less than I? For each row I, there are no security devices on the ith row. Now this one though, because row 2, column 3, 0, 1, 2, 3, goes to this one. So I would think this would actually break the rule, because to me this sounds like for each row I, where R1, the two devices are located on two different rows, okay, for each row I, where R1 is less than I, less than R2, there are no security devices in the ith row. R1 is less than... That's interesting. Yeah, this piece to me is a little bit confusing because I thought this meant that like there needs to be at least one row in between security devices, but here there's not. Although I guess yeah, it's weird. There's one beam in total. There are 8 beams. Well, let's think about how to do this. Maybe that's not really, maybe I'm not thinking about this the right way. This condition, maybe the answer will become more clear as I start working through it. So how do we even start tackling this question, and what is it that we actually need to do here? If I'm standing on like any grid cell, what's like the easiest way for me to see if there exists a beam, or rather 0, 1. I guess for any of these, well, couldn't be for the next ones. Second row contains security devices, which breaks the second condition. Oh, this just means there cannot be any conflict. It needs to go to the next beam, I guess. Or it needs to go to the next cell that has a security device. There can't be any like conflicting. I can't go past a row. I can't go from like here to here because, okay, I see what that means. So it needs to just like hit the next available one, but it can't go any further than that. So it's like how many ones on this one can hit how many of the ones down here, and how many of the ones here can hit how many of the ones down there. So if I draw this, kind of want to, all I'm doing here, I'm just expanding the array a little bit just so I can see a little bit more clearly. So we want to match, I mean, what if I did, and obviously I think a very brute force method, if we knew, because I only care about like this row's empty, so that's fine. So I just need to go from this row until the next row that has security beams, and that would be this one. And there's 2 here, so like here there's 2, and here there's 3 beams, here there's 2 beams, and here there's 1 beam. Which means that I can do 3 times 2, which is 6, and then 2 times 1, which is 2, and 6 plus 2 is 1. Maybe that's like, I don't really know if that's like even the right path of thinking, but maybe we can do something like that. What if I just count? What if I just iterate? What if I have something like previous row and current row? So I'll just start iterating over all of them, and I'll say, okay, this is the previous one, and then we'll go to this one. I'll count all the rows, or rather, all right, let's do this. So previous security, actually, I might as well just start coding it how I think it could work. Let previous devices equal 0, and let current devices equal 0. What if here, like I start at this row and I count all my devices, so I have 3. I go to this row, I don't have any. I go to this row, now I have 2. So once each of them are non-zero, maybe I can multiply the answer, and I'll add that to the total number of beams, and then I'll reset previous devices and current devices to 0. Or I'll make previous devices current devices, and then I'll set current devices to 0 and do the next thing. Now, let's see. Yeah, if current devices or if previous devices is ever 0, we just keep going. I guess we always count the number of ones. So we count number of devices in a specific row. Let's see. Let me like try that out. I'm gonna do let previous devices, let current devices, let total number of beams. I want to explain something real quick that's not really related to the question, but excuse me. A lot of times you might see me like, how do I group variables? Sometimes I like to do things like alphabetical order. So, I mean, for this one, I might just say current and previous, just like this. And then you'll see that let total number of beams is its own line. Now I can put them all like this and it'll still satisfy the alphabetization, if that's even how you say it. But here I'm sort of grouping these together where like these two variables refer to devices and this variable only refers to the total number of beams so far. So they're kind of like, they're similar but not exactly the same. They don't mean the same thing, and that's why they each have their own group. So I wonder if we can do, for let row equals 0, row less than bank.length, row plus plus, for let column equals 0, column less than bank of row.length, column plus plus. So here we can say, I guess I can say let bank devices equals 0. Here we can say if bank of row column is equal to 1, I can say bank devices plus or equals 1. So let's say we get to the end of this and this is 3. Okay, so let's see. Maybe I want to make this a little bit clearer because I feel like having these as numbers might make things trickier because, for example, I wanted to say something like, oh, if previous devices is 0, then I should set that. Now, can that work? Maybe that can work. If previous devices is equal to 0, what if I said previous devices is equal to bank devices? Else if current devices is equal to 0, then we'll still say the same thing. Current devices equals bank devices. But at that moment, we can say total number of beams equals previous devices times current devices. And then we should set previous devices equal to current devices. And then finally, current devices equals 0. And I think maybe we can get something with this. Let's go through it like I always do. I'm gonna just move these, or actually let me move this whole picture up here. And now let's go through it. So I'm just gonna recopy these so I can have like, just consider this our little workspace, right? Okay, so we're going through each row. Bank devices is 0. For let column equals 0. Okay, so we're going to go through each one of these. We're going to have bank devices be 3. So if previous devices is 0, which it is, we're going to set previous devices to be 3 here. Now we're going to go to the next row. We're going to count all these. Bank devices is 0. So previous devices, let's see, previous devices is 3, so that's not 0. Else if current devices is 0, this is where it becomes a little bit tricky, right? Because, yeah, we need to say, I think for any of these, if we get to a row where there are no bank devices, then we can skip it. So I might open this up a little bit and say, if bank devices greater than 0, and maybe we can stick all this stuff in here. So here we say if bank devices is greater than 0. So here, for example, like bank devices was 3, so we set previous devices to bank devices, right? So that gives us our 3 here. We get to this next row, bank devices is not greater than 0, so we just go to the next one. Now bank devices is 2 for this row. Previous devices is not 0, but current devices is. So current devices becomes 2. Total number of beams is previous devices plus times current devices. So this becomes 6. And let's make this plus or equals because we're going to add the previous total number. And then previous devices equals current devices. So this becomes 2 and current becomes 0. Then we get to the next row. So here we do 1. So bank devices is 1. Previous devices is not 0, so current devices, oh, here we go. Else if current devices is 0, which it is, current devices equals bank devices, total number of beams plus or equals previous devices times current devices. So that's 2 times 1. And then we add the 2 to this. We reset current devices to 0, and then perhaps we can just return total number of beams. Maybe that's a way of doing it. I want to see this next one here. Because here, let's see, we'll have bank devices is 0 here, so we don't do anything. Then we come over here. Now we set previous, right after this, current bank devices is 3. So we set previous devices to 0. But then when we get over here, it's still 0 bank devices, so we don't do anything. So total number of beams is never updated. Now I think just from going through the exercise now, I'm not sure I need current devices. I might be able to just use bank devices. I think I can just use bank devices. Because I can say if bank devices is greater than 0 and previous devices equals 0, previous devices is bank devices, else if, so if bank devices is greater than 0 and current devices equals 0. So if we get here, we know that previous devices is set, but instead of setting anything with current devices, I think we can just do total number of beams plus or equals previous devices times current devices. Previous devices equals the current bank devices. And then that should be it, right? I think that can be good there. Maybe we can do an else here. I think that would work. And then we can remove current devices. I'm waiting. If Steve is around, I have a feeling he'll say, oh, you can remove lines 16 to 24 just with one conditional check. I hope he is. And I say that in the, like, I say that joke in the best way possible. It's because, like, you've given me great advice, so I just think it's funny. Maybe we can do, if bank devices is greater than 0, I guess this needs to be the same for both. Well, let's just go ahead and run this and see what we get. At least for that first one. 8 and 8, okay. For that next one. Get 8 and 0. All right, let's run it. Are we gonna start off strong? Wow. Okay. Damn, this is awesome. I swear I have looked at this question before and I have never finished it. And now I did. So I mean, like, the work, okay, to the people that are listening, the work we're doing here is real work. I mean, this is the grind. The grind that you've all been watching me do, this is it. This is the grind. Because I have seen an improvement in the way that I'm able to tackle these questions. And I honestly, I can't say that, like if you were to ask me, oh, have you seen this pattern before? Or how were you able to recognize it? It's not really so much that I was able to recall a specific pattern. I think it's just more of intuition, like something just kind of clicked. And I'm not even sure if this is the most optimal answer. There might be a better algorithm that we can use for this, but I'm just extremely happy of the fact that I got it right, because I've a long time ago, this one is the rule of product. A long time ago, one of the moderators on my Discord, his name's John, is it John Downey? I was about to say John Taylor. I don't know who John Taylor is, but John Downey. John Downey had solved this question, and I remember, he was feeling happy. And I remember looking at the question and being like, dude, this is like God level question right here. And we just did it together. So, I mean, pretty amazing. I feel like I can probably, let me see. Well, check this out, right? If previous devices equals bank devices always happens. So there's definitely room to refactor here. Let me see if I can spend like a minute or two on that. if bank devices is greater than 0, if previous devices equals 0, previous devices equals bank devices. If bank devices is greater than 0, then total number of beams plus or equals previous devices. So I need to set the previous devices once. And that's always going to happen. And then once I've already set the previous devices, let me see. Maybe instead what we can do is if previous devices greater than 0, maybe here we can do total number of beams. And then at the end, we'll just say this. I think I can do this. If previous devices is greater than 0, that means it's already been set to something. And then we can just keep doing that. I think that can work. Let me run that. And then there might even be more room for improvement here. 8 and 0, 8 and 0. Wow, okay. I mean, again, I'm not saying that, like, I don't know if that alone made anything better, but can we even do better here? So if bank devices is greater than 0, because if we change these together, if we say if bank is greater than 0 and previous devices is greater than 0, I mean, I guess I can I just always do this even if it's not the case? Because even if it's 0, that's fine. I'll only ever do something if it's greater than 0 anyway. So let's see, let's do our last one here. So if I remove this, I say and previous device is greater than 0, we'll remove this guy, put that in there, take this out, put this here, and then what if we just always update this? Can that still work? Okay, no, that doesn't work. If bank devices are greater than 0 and previous devices is greater than 0, previous devices equals bank devices. But I guess here I'm resetting previous devices instead of keeping it if it is greater than 0. So maybe this is the better way of doing it. But I think this is, I'm pretty happy with this. 8080. And now running this a couple of times, it seems like this could be, I mean, we've consistently gotten over 95%. So I think this could end up being an optimal answer. To find the total number of laser beams, we have to do two things. We have to find the number of laser beams between adjacent rows. A row here is considered only if it has at least one security device. Otherwise, the row is simply ignored. Ignore row 2 and say, okay, doing step 1 only solves part of the problem. We now need to find the sum of all the laser beams from each pair of adjacent rows. Right, there you go. Nice. Yeah, pretty much exactly what we got. String s bank, count equals 0. They add all this up. If count, bam. And I guess they're not even, yeah, we can probably simplify a tad bit, but I'm ecstatic, guys. This is like, I promise you, I never even thought I would get close to this question. And now we're doing medium questions. Like, that's just crazy. We were doing easy questions. Now we're over here doing medium questions. Having a great time. This is now one of my favorite questions. All right, sweet. Let's see if the next one is going to treat us nice. Maximum twin sum of a linked list. I'm going to have a sip of water. If you guys have water, have a sip of water. All right. In a linked list of size n, where n is even, the ith node 0 indexed of the linked list is known as the twin of the n minus 1 minus ith node. So if 0 less than or equal to I less than or equal to n divided by 2. All right, I just want to see what they're doing. 5, 4, 2, 1. Nodes 0 and 1 are the twins of nodes 3 and 2 respectively. All have twin sum 6. There are no other nodes with twins in the linked list. 4 and 2 and 2 and 3. The nodes with twins present in this list are node 0 is a twin sum of node 3. And that's because a twin sum of 4 plus 3 equals 7. Node 1 is the twin of node 2. Oh, are we just doing first and last? 5 and 1. Nodes 0 and 1, where n is even the ith node of the linked list, is known as the twin of the n minus 1 minus ith node. So shouldn't this be of nodes 3 and 2 respectively? Shouldn't this be 0 and 1? Okay, no, yeah, this is, I think this is being drawn differently because 5 and, or nodes 0 and 3 are twins, right? The twins of nodes 3 and 2 all have twin sum 6. So 4 and 3 is 7, and this is, okay, so do they just want us to start from the outside? I think it's almost like we just add like 5 and 1, and then it's almost like a 2-pointer, and there is, I think there's one way that we can do this. The first thing that comes to mind is a technique I've used before where I'll have like a global head that points to the head. And then what I'll do is I'll have a recursive function that goes all the way to the end. And then once I hit the base case in that function, I just start doing my twin sums and keep doing that until my head pointers next is equal to the value of whatever node is part of that recursive function. I think that's one way we can do it. Another way that we can do it, I don't even know if this is like the best way of doing it, but we could reverse, we could sort of like reverse the list, but that also seems kind of annoying. I almost think, given the head of a linked list with even length, return the maximum twin sum of the linked list. We can also like put these things in a stack, but that's using more space where we won't, or maybe don't need it. So let's do something here. Are we guaranteed to have at least one node? Okay, we have at least one node, so I don't have to check for a null list. So let's say, I'll just call this like temp head equals head. Here I'll say let max pair sum equals negative infinity. And then here I can say const iterate. This is just going to be h for head. Here I'll say if not h, we can just return. I'll just call iterate with h.next. Now when I get here, right, like if you think about this one, I'm going to call the iterate function. It's going to do iterate with head. And then here we can return max pair sum. So imagine that I start my head here, like the head of this iterate function. I'm going to go next, 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 next. When I get here, I'll return. So now h, the h variable inside of this will be pointing to 1, and my temp head will still be pointing to this. So we could say max pair sum is equal to the math.max of max pair sum, or temp head.val plus h.val. And then from here, I should be able to do temp head equals temp head.next. Now the only thing is like number of nodes in the list is an even integer in the range 2 to 5. This is going to be like, there's got to be, I think there's a better way of doing this where I can just, I only want to iterate to like the halfway point, because this is still going to iterate all the way to the end and then all the way to the beginning, right? So it's essentially going through the whole list twice, and even the max head, like at some point Actually, at some point, we're calculating twice, right? So even if this works, I really don't think this is the most optimal way because we're doing multiple calculations. Six and seven, 6 and 7. So we still, I mean, it looks okay based on the values here. But let's see, it might be time limit exceeded. Or not, okay. But 26.5, we can do better. I think exactly. That's what I was thinking of doing. Fast slow pointer to mid. And then I can just iterate. Exactly. And then maybe we can just do the same thing, but instead of starting from the head, we just start from the mid. I think that's the way to do it. Let's try that. I like that idea. So let's do slow equals head, fast equals head. And it will be, if it's 2, I guess it can be, will it always be, let me see. Oh, and this is even, right? So if I move 1 here, this one moves 2, that's fine. This one moves 1, this one moves 2. Okay, that's fine. All right, we go 1 here, this one moves 2, then we go 1 here, this one moves 2. Okay, so we can say while fast, slow equals slow dot next, and fast equals fast dot next. Maybe here we just iterate on slow. That might make things a little bit faster, because now, and then here, how do I only go to slow while fast? Because then inside of here, well, let me see if this still even works. 6, 7, and 1001, okay. Now, runtime here is 60 milliseconds. Before we were getting what, 278? No. What did I get on my previous ones? Well, let's run this anyway. 36.17. So that still works. Now we're only iterating from the midpoint. But let's see. I'm just gonna run it one more time to see the percentage here. If it's just like, okay, so I'm still getting, I don't want to say unlucky, but there's still a better way of doing this. Because we need to be able to do the first one and the last one. The recursive thing will be nice because that on its own is going to go back. But maybe, well, this is still going to be good because, yeah, we're only going, like this would be what? The time complexity if we think about this, right? This right here is going to be O of n divided by 2. Iterate slow will also run. So this, I mean, to me, it seems like this whole thing is just linear. Temp head dot next. Maybe the recursive calls is what is not the good thing. Wow, it's really bad. I wonder, is there a way 0, 4 or 0, 1, 2, 0, 3, 1, and 2? So is that the thing? Like we just reverse the other half and then we just 5, 1, 4, 2. I guess we can do that. And then at the end we just again iterate. But that seems like so much extra work. It's like we got to go to the midpoint and then starting from the midpoint we do a reverse linked list question essentially. So I guess that'll be, and then at the end we just go O of n. Because wouldn't that be the same time complexity? Although I guess because we're doing it iteratively. Reverses other half on slow pointer. Reverses the other half on slow pointer. This one moves 1, this one moves 2. I guess we can do that. I'm kind of lazy, but let me see. I'm gonna try to pull up my reverse linked list. I know we did that one before. Oh, really? Nice. So like, we just copy this. Let's remove this. Let's do this. Const reverse list function head reverse list head.net. Oh wait, this is, no, I did this one recursively. I want to do it. I want the iterative one. Is it the first one? That's funny, using previous work. Okay, let's try this. So we have temp head. So let me move all this stuff. Let me put this on top. We have let slow fast head. Okay, while fast, slow.next, fast equals fast.next.next. Now starting at slow, so we could say, oh no, but then, will that actually work? Let's see. Reverse list at slow. So then we should have 5, 4, 1, 2. Now is slow, I forget if slow is still going to be pointing to 1. Can I like console.log my list right here? I know a lot's going on, but I want to see what we get. Return max pair sum. Okay, that's fine. Let me just comment that out. So 542. Oh, 422. Well, actually, that didn't do anything. Oh, fast, reverse list, return previous. Is this getting out of hand? This might be getting out of hand. So return the previous head. So is it because maybe I don't want, it'd be nice if I had the previous one of these, because then I can say like this dot next. Yeah, that's annoying. I think I get what you mean though. Like this reminds me a lot of linked list palindrome, because that's essentially the same thing we do. We just reverse the linked list halfway and then we do the same thing. But I felt like the recursive solution, at least doing it like this, is kind of the same thing. We're just using recursion, but as we're seeing, that apparently is really terrible. Now, is that because we're using JavaScript? Can we look at the discussions? Is that cheating? Okay, can we, let's look at like the headers here. Okay, Python mid and reverse, variation of palindrome. Okay, well, what's the two-pointer approach? Is that not the same thing? Oh, okay, they're doing the same thing. All right, so I guess that is the best way of doing it. I'll leave it like this for now, since, I mean, I don't think I'll gain any more value from it, since we know that we already know how to reverse a list. Once I reverse this list, then we can just use both those pointers and continue adding them to get the same answer. So I think with what I have here, I guess that's, to me, that's okay. That's good enough. So I'm going to go on to the next question here. Feeling really good about today's questions. So let's keep going. All paths from source to target. Oh man, I'm like notoriously terrible at graph questions, so I'm happy to do some of these live. I already feel like I'm gonna like this. So, given a directed acyclic graph, DAG of n nodes labeled from 0 to n-1, find all possible paths from node 0 to node n-1 and return them in any order. There's a list of all nodes you can visit from node I. There is a directed edge from node I to node graph of ij. So I think one thing that my friend John showed me is like we don't, a lot of times we're forced to create like an adjacency list, but this, if I remember correctly, like this already has all the nodes, right? Each one of these different subarrays represents the node itself. So this is saying that from node 0, there's a path to 1 and 2. From 1, there's a path to 3. From 2, there's a path to 3. And from 3, there's nothing. So, and it wants us to go, so here we want from 0 to n minus 1, and that's 3. Okay. So I think, if I remember correctly, the way to do this, since we know we're going to be starting at 0, I mean, we just start from 0, right? So if we do 0, 1, what's the best way for me to draw this? Maybe I'm going to do this. Wow, that went so much further than I was expecting. Let's do this. Let's do this. Remove this. Let's do that. Okay, so from 0, we go to 1. And that's like, okay, we just use the 1. And then from 1, we go to 3. And that's like one path, right? And now we just recurse back to here. We go to 2. From 2, we go to 3. And that's cool. And that's what, 2 paths? So that should be good. So 0, 4, 3, 1, 4, 3, 2, 4, 3, 4, and then this one. So I think what we can do here is, if I'm looking at it like this, let's think about this, right? All path source target, and it wants us to return an array. We can have our graph, we can have the current path, or I can just say path and paths. So what is it that I'm going to pass to graph here? If I call it with 1, 0, 1, I can pass in a node to each one of these. We're always starting here, so we have 0, 1, 2, 3, 0, 1, 3, or 0 to 4. Oh, okay, no, we're going to 4. I want to like, I wish I can have, well, digital whiteboarding here is tough, but do I want to pass the graph here, or do I want to pass a specific node? I guess to my path, I can just add the node, and whenever I get to, if I see that my path, what if I did something like, if the thing on my current path, if path, let's see, if path.length is greater than 0 and path at path.length minus 1 is equal to graph.length minus 1, because it's always going to end with either 4 in this case or 3 in this case. Let me put these on multiple lines here. Then we could say paths.push path. Oh, and then maybe here it wants us to return what? Oh, we can also return paths here. Else, or we can just go to the next thing. Else, what is it that we want to do? So we're currently sitting, let's see, for each one of these, for let I equals 0. So I just need to go through, I only need to go to the beginning, right? 0 to 4, then it has all these. 0 to 3, it has all these. 0 to 1, we go here to 3, 2, 4. What's the best way for me to do this? I want like a better way to draw it out. Because what if we did, for let node equals 0, node less than graph.length, node plus plus, for const child of graph at this node const new path equals, let's see, take the current path and then we add that node child, and then can we just do all paths source target? Here we'll pass the graph new path and paths. Like, is that a way to do it? Now what's gonna happen? Let's just go through this real quick, right? So for let node equals 0, so we're here, const child of graph node, we'll create a new path of, well, we already messed up because we need 0. So it shouldn't be, oh, the node is the actual, it shouldn't be, yeah, I think I need a way to pass the node too. This is classic like graph traversal. I'm just butchering this at this point. I can go from 0 to 4, and then I go to 4. Well, 0, 1, 2, 3, 4. That's already the end, so that's good. And now I can go back to 0, and now I can explore 0 to 3. I go to 0, 1, 2, 3. That takes me to 4. That's the end, so that's good. Then I go here. Okay, 0 to 1, that's good. And then I go to the next one. Now I'm at 1. I can go from 1 to 3. Or can we? No, I need to draw this out better. Because they're only dealing with 4s here. If I go from, let's just do this one by one. Okay, I'm at 0 now. I'm going to consider 4 first. So I'll immediately use a 4. Then I'll go to index 4, so 0, 1, 2, 3, 4. There's nothing there, so that's the end of like that path. Now we're back at 0. We're going to use a 3, so we'll add 3. 0, 1, 2, 3, and then that's a 4. We use the 4, and we're done there. Now we're back at 0. That's 1. So we go from 0 to 1. Okay. Now we're at 1. We use a 3. 0, 1, 2, 3. See, but maybe it's not that I use the 4. Like that's, maybe I'm messing up there and saying that like, oh, that's it. We use the 4. As 0, 1, in 1, we can go multiple ways. We can go 1, 2, 4. Okay, so I think it's like we call, we're at 0. And from 0, we call all of its children. All those children call all of its children. And we continue doing that until we get to node 4. And I'll know that I'm at node 4. How is it that I want to do that? How do I want to know? Well, I guess at any point when I get to 4, all right, if I'm at node 0, if I'm at 4, that can be my current path. But maybe I also want to pass this node in here. Okay, what if I also passed in node? I don't think I need this, but it might make it a little easier for me right now. I'm tempted to pass in node here. Something like this. Now it makes sense a little bit more. So if I do this again and I redo my base case, I can say if node is equal to graph.length minus 1, then we can say const, or I guess we can just say paths.push path, and we return paths. From here, what I should do is I can say const new path is equal to path and the current node that we're on, which we're starting at 0. And then let's see, for the current node, I guess we can just do for const. What would I call this? Like direction or something, or edge? I guess for const edge of, or we can say for const node of graph for const edge of node. Now maybe in here we can just say all paths passing in the graph, we'll pass in the edge, we'll pass in new path, and then we'll pass in paths. So what will this do? Let's try this whole thing again now. So let's use this as our example. Okay, so as soon as I start this, I create a new path with anything that's in path, which is nothing, and node. So my new path currently is 0. Then I say for const node of graph, so we are starting right here in this first one. For const edge of node, we can say all path source target graph and edge, which is just 1. Oh, but see, we don't actually want to go. It's not supposed to be, we're not supposed to go const node of graph. I think at any point I need to be able to index into whatever I passed into here. I think I should be able to say for const edge. Yeah, maybe this should be this. Maybe it should just be this, and this should be node. So const new path is 0. Const node of graph at 0. So the first one's going to be 1. We'll call it with graph, node, new path, and paths. Okay, so we come in here. Node is 1. That's not equal to 3. So now we add 1 to here. And the node is 1 in this case. Now we say for const node of graph at 1, which is 3, we again call it and we go 0, 1, or we pass in 3 here. New path. Paths, we go over here, it's not the same, so we add 3 here. For const node of graph node, here we have none. Now should I maybe construct this before we ever get here? That way I can say if node is equal to graph.length minus 1. We're already at the end, so don't do anything. Return paths. Maybe that can just be it. Kind of just want to go for it and see what we get. Oh, and of course we have to return paths. Am I like missing something here? Because this keeps indenting in a weird way. Yeah, and then graph of node here. Cannot access node before initialization. Did I miss something? Graph, node, path, and paths. For const node. Oh, okay. For const, maybe this should be edge, I guess. Zero, 1, 0, 2. So we're sort of almost there. However, if node equals graph.length minus 1, oh, paths.push new path. Should push the new path here, no? 0, 1, 3, 0, 2, 3, okay. Zero 4, 0, 3, 4, 0, 1, 3, 4, 0, 1, 2, 3, 4, 0, 1, 4. Nice. So let's hope we get it right. Sweet. Okay, that's cool. Although I don't think I need node here. Do we need node here? Maybe. Now I want to try and figure this out because I always get confused about the time complexity with these things. So how many ways do we have to go? I think just like a normal graph traversal here. I think I normally hear like all the vertices plus edges, because we are going to all the different vertices. We're going 0, 1, 3, but then we're going 0, 2, 3. So in that case, we hit all the different vertices and all the edges, right? That's the time complexity, because in this case, we go 0, 4, but we're never going to go this way again, right? Because just the recursive nature will take us to what? 0, 3, 4. So we're done with this triangle. We go 0, 1, 3, 4. We're done with this parallelogram, if that's what it's called. I forget. Is that what it is? Parallelogram. Nice. Wow. That's literally the parallelogram right here. We're done with the parallelogram. Then we go 0, 1, 2, 3, 4. We're done with this. And then 0, 1. Wait, 0, 1, 4? Oh, 0, 1, 4. Okay, then we're done with whatever that is. And now the space complexity here. See, is this just the length of the longest path? Because we'll sort of be building up. And how do we explain that? Well, I really do want to see this. Iterative backtracking. Count from start to target in topological order. Count by DFS with memo. Node n to node -1 and node I. Res that pushback. Path dot pushback. Wait, is this not what we did? Path dot pushback current. If current, okay. Else for auto DFS path dot pushback. If it asks just the number of paths, generally we can solve it in 2 ways. I didn't do that in this problem for the reason that it asks for all paths. I didn't expect memo to save much time. Imagine the worst case that we have node -1 to node -n. If there are 2 paths and in all paths, we can roughly say, oh, 2 to the power of n. I think the time complexity is 2 to the power of n, so I'm not thinking about this correctly then. All right, pretty good application of a DFS algorithm here, although a BFS might have worked as well. But since I just finished recently 2 other BFS problems, I got a bit bored with it. First of all, we know it is a directed acyclic graph, which means we do not need to keep track of previously seen nodes to avoid cycles. Okay, that makes sense. Now, okay, that makes sense, right? It's directed and acyclic, no cycles, okay? A nice relief, not that having to implement that logic would have killed performances, at least in the 2 to 15 size range that it was declared in the description, or required too much code. First of all, we declare a few class variables, also to avoid having to drag them around with each recursive call. Res is our final result container. Temp stores the sub vector we are building. Target finally is where we decide to stop. With that done, we go to our main function and set the value of target to graph.size -1. Not great math or logic needed here, just reading from the description. Then we call our function passing down only the graph itself. We know the starting point is always going to be 0, so we can default current node to that in our DFS function. Inside DFS, okay, so we update temp. If the target is met, we do res.pushback else. Now backtracking with temp, I guess in my case, I'm cloning else for, and then they're doing temp pop back. Maybe the temp pop back is easier instead of having to recreate a new path every single time. Is that why it's okay for them? Because they return the path here. Path.push new path. Return paths. Is that what Lee did? Wait, let's see, backtracking. Vector path, return path, path.pop back. Is the pop back, is it actually faster? Because I think maybe because I'm like creating this new path every single time instead of just pushing to it. Because here I'm cloning it. I could just be pushing to my new path. Let's see, path.push. Path.push, it was what, node? If node equals graph.length, path.push path. return paths. Now, can we actually say here path.pop? Would that even work? I'm just curious. I don't know. All these are reference variables, so it might. New path. Output 0, 1, 2, 0, 1, 2. Okay, so I think, well, this is wrong. We can fiddle with it later, but I think the reason that mine was taking longer, seemingly longer, is because maybe that cloning of every, I'm cloning the path every single time and concatenating it with the current node, whereas for them, they're just either pushing to the current path or popping, which are both constant time operations. So that can help me a lot here. I think I should probably figure that out. Well, I mean, if we just do paths and paths, then they just call it with that. Else for, and then they're just returning paths because they're creating this helper function here. Oh, and that makes sense because the next time we call it, we'll come over here, we'll push it to path. If it is the target, then we push it. It doesn't enter the else, and then we just pop back. So I want to try something. I do want to have these side by side. Let's go back to the solution that we pretty much came up with on our own. Like, I'm not discounting that at all. And I guess what we can do here is something very similar where maybe this can be my DFS function. Let's say var DFS. What are they taking in here? They have their G, which is their graph. They have the results, which is paths. Oh, I think they have everything the same. Yeah, node equals 0. Everything else is the same here. The only thing is they're immediately pushing to path. So path dot push node. Here we can say else. Yep, so the same thing here. So if node equals graph.length minus 1, paths.push new path. So we can just remove that return. We'll just push the current path, else for everything inside of node, we'll just call this with graph edge path and paths, and then down here we'll just pop paths.pop. And now let's just get our, oh, I should have kept all paths source target. Yo, what's up, Marvin? Let me actually copy all this just so I can get the signature of the function back here. They just gave it to me with graph, right? Okay. I think they originally just gave me graph. Can put this here, can move this there, and now we'll just do the same thing. So they said we'll create const paths. Or actually, we already have path and paths in there, although I think we need this one. Yeah, we'll say const path. So you can say graph 0 path and path. Wait, what am I doing? DFS with graph 0 path and paths and return paths. So let's see, because this is, I was always used to creating, like cloning an existing array, creating the new one, and now we get this issue here. Oh, this should be calling DFS. Okay, let's check it one more time. So the DFS here, we have our G, which is the graph. We have our result, which to me here looks like all the paths. We have our current path and our current node. So here we're gonna push path.push node. That sounds fine. If current equals g.length minus 1, okay, we just push path. That's cool. Else, same thing for const edge of graph of cur, which is our node. We'll just call DFS with graph result. And then what is IT here? It, oh, which is just the node, right? that's just the current, which is 0 to begin with. All right. Else for, and then we do paths.pop over here. Cons paths, graph 0. Seems okay to me. I'm not really sure what's happening here. 0, 1, 3, 0, 2, 3. Return paths. If node is equal to graph.length minus 1, DFS of graph. What are we passing here? Function graph. I want to see something real quick because I changed the signature up. So like, I don't know, does LeetCode like that? Okay, that's fine. Path and paths. Return paths. Path.push node is 0. Path.push path. Path.push node. Okay. If we do console.log path here, oh wow, 0, 0, 1, 0, 1, 3, but then we're also, it's just continuing on. Path.pop. Oh, path.pop, right? I think this should be path.pop. Yeah. Let's see. Okay, I thought that would have helped. Path.push path. Path and paths, graphs. We have edge of graph node, graph.length, console.log path. What do we have now? Okay, 0, 0, 1, 0, 1, 3, okay, and then 0, 2, 3. So if node, path.push node, 0, 1, 3, if 3 is equal to graph.length minus 1, 0, 1, 2, 0, 1, 2, 3, okay, paths.push path. So why isn't this path.pop? I'm not sure why path here is not being updated. I mean, this is it because it doesn't like, does it not like that I'm, oh, that's bizarre. I was really hoping that would have worked. But I feel like, at least from the console log, it looks like it's working. I'm really not sure why that's not working here. It's okay. I think we mostly got the bulk of it today. I'm really happy with the questions we did today. I think we did, what, 3 of them? Started at 301. 304. I mean, 3 medium questions in an hour, I think is pretty great. Like, I think normally medium questions should take about 25 to 30 minutes. So we averaged about 20 minutes a question. Granted, let's see, one of them, which ones did we do? I had never seen this one. I'm very happy about this one. And both of these I have sort of seen before. I just don't really remember how I had solved them, but I guess I'm a little bit lucky in the fact that I've seen them before. But really, number of laser beams in a bank, super, super proud of that. I think that was a fun question. Marvin asks, how you doing? Good. How you doing? Good today. Yeah, I'm doing good, man. It's Thursday. I'm going on vacation soon, so things are looking pretty great. Speaking about that, just to end up the stream here, so I already have, I've been doing recordings after these streams for the last 2 days, so that way when I'm on vacation, I have scheduled videos that will be coming out during the time that I'm on vacation. So you guys are still going to be getting videos. It's going to be transparent to you. You don't have to worry about anything. I got some fun, like, festive videos coming up for the holidays. I'm super into that stuff, so hopefully that will kind of spice things up, make it a little fun. And if you want to see all the questions that we've done, I updated my site, so now we're at 154 easy questions for medium. Zero hard. I'll be updating the medium section today since we did 3 of them. I liked all 3 of the questions, so I'll probably go ahead and add all 3 of the questions. So that's gonna be nice. If you like what you saw today, make sure to subscribe to the channel. It helps me out a lot. It keeps me really motivated to keep going. I mean, I'm so close to hitting 500. I can't wait so I can unlock the community feature and just become a lot more interactive with everyone. If you're watching on Twitch, make sure to come to the YouTube because I have a lot of content that's exclusive to YouTube there. So yeah, just looking forward to continuing to interact with you all, having a great time with all this stuff. So you guys all have a great rest of your Thursday and happy coding. See you all next time. Later.